Hello and good morning. My name is Connor Daniels. I am the foremost science expert on toaster science ology. Listen, we all love toasters. Look at this little guy. Isn't he adorable? You're adorable. Now let's see what's adorable on the outside is inwardly adorable. The answer, in a word, no. I've taken the liberty of taking this never been used straight out of the box. Poor little toaster. Brand new. Just purchased it straight out of the box. This poor little toaster. And in the name of science, I had to dismantle it, piece by piece. Damn you, Kruger, you drove me to this! Alright, so looking at the innards of this baby, we can see some very simple electronics. Of course, you have your standard sheet metal box, as well as some small circuit boards. When you bring the hand down to initiate toast protocol, they connect these two pairs of contacts. They then provide the power for the toaster. To make the handle lock in place, there is an electromagnet below it that holds it in place as it turns the bread into toast. You guys remember electromagnetism from, that thing. The small rudimentary processor chip, what settings you have on your dial, which doesn't mean time by the way, and if you're bageling it up, that's how long your toast is going to cook for. And when the count is up, it cuts off its own power, making the toast go up in some kind of end of Terminator 2 robot suicide for the greater good of not burning your bagel. Now, let's look what happens when the toast pops up. There are two springs inside this toaster, but one is less important, so let's focus on the other one here. The law of springs, if I am to slap this handle down with a mighty 10 newtons of force, then the spring, if we are not accounting for it lifting anything, will come back at me with 10 newtons. If the spring is pushing up with more than 10 newtons, then my hand might not get all the way there. The equation for this is simple. F equals K times delta of L. The delta L is the change in the spring length from here to here, for example, on the paper. K is the spring constant. Let's flip it around. K equals F divided by the L delta. F, force, equals mass times gravity. To find mass times gravity, you test the spring with different masses and see how far the spring extends. If all goes well, this should be a straight line and your spring does not break or anything. In other words, taking off the mass will make it go back to 0. Your gradient of this line is equal to m divided by x. Then simplify k, and it equals your radiant times 9.8. So back to the toaster. When you push down the handle, you are storing all that potential spring power in the coils, and when it's released, it will spring back to its original position, carrying the toast to the top of the toaster and making it so you can grab it without burning your hands. Come on. Oh. Kinda sucks, but I guess this is the only way a toaster can work.
This is one of my favourite old technological artifacts. As you see, when we put the toast in, it goes down delicately and slowly.
Wait, what?